Hi all, my name is Abhilash and I'm watching Code Spectrum, and in this tutorial we're going to solve these three problems, and note that this is the third part of the tutorial, so make sure you watch the other two parts as well. Let's take the first example. In this example you have two terms, but if you're thinking that you may apply the DI's method, but you are wrong, because in this DI's method you somehow don't know the integration of some term and you may not know the differentiation of other term. Okay, so in this method we're going to solve in different strategy. In such problems you need to apply some algorithmic steps to figure out the solution, so make sure that you follow my steps. Take out cos x from the integral. How? See this. We have broken down the cos cube x into cos square x into cos x, and the square bracketed cos square x should be converted to sin x. Since cos square x is equals to 1 minus sin square x, we can replace this value in this equation. The equation becomes this one. Now what can you do is you can do the U-substitution method to solve this integral. You can substitute sin x is equals to u. Differentiating both the sides, you get cos x dx equals to du. You can replace the value of sin x by u and cos dx by du in this main equation, and the equation dissolves into simple algebraic equation. Now you can distribute this u power 4 into the bracket parenthesis, and you may solve the integral. The answer to this integral is u power 5 divided by 5 minus u to the power 7 divided by 7 plus c. And lastly you have to replace this u by sin x, because we need the answer in terms of x. So this is the final answer. Let's try another example. In this example we have second to the power of 6x. Okay, in such case you need to extract second square x from the integral like this, and now you need to convert second to the power of 4x into the 10x. Now how we can convert this is, we know that 1 plus 10 square x equals to second square x. Now if we square the both sides, then you will get second to the power of 4x, and we can substitute the value of second to the power of 4x into the main equation. Now this is the answer. Now can you solve this integral? Yes, you can, by the help of U-substitution. So you can now put the value of u as 10x. Now differentiating both the sides, you get, now by the help of these two equations, substitute the value of sec squared dx as du and put the value of 10x as u, expanding the 1 plus u square whole square. Now you can integrate each term separately. Okay, you get this whole equation, and lastly you may replace the value of u with the 10x, because we need in terms of x. Okay, now already we have solved these two problems. Let's discuss the similarity and the difference between these two integrals. Now if you see the first integral, we were extracting cosecant x in the first place. It means that we want to have the U-substitution of sin x so that we can have the differentiation part, so that the integral can be solved. What would happen if the 3 is replaced with 9? Then all the solution remains the same, except that when we extract the cos x, the remaining part should be 8. Now can we solve it? Yes, we can, because when the power of cosecant x is even, we can convert this cosec into sin x. Just we need to take both the sides to the power of 4, and you can substitute the value of cos to the power of 8x in the main equation, and you can substitute the value of sin x and solve the entire equation. And in second case, where we integrated the second to the power of 6x dx, we extracted the second square x. This second to the power of 4x can be converted into 10x, and also you can substitute the value and solve the integral. But what if in place of 6 it would be 10? then nothing changes. Only the change is in the second to the power of 8x is being placed in front of the second square x. So we can convert second to the power of 8x into 10x because it is an even power. The second x is a even trigonometric ratio and it is having even power, that's why it is valid for this rule. And also in this case, the previous one, we have the sine x, which is an odd trigonometric ratio, and we have an odd power with the cos x, so it is valid for this rule. So mainly, let's discuss another problem where this rule is violating. Sine to the power of 4x, we have an odd trigonometric ratio having the even power. It is not valid for this rule, so we need a different path to solve such problems. So mainly we can write sine to the power of 4x as sine square x whole square dx, and we can substitute 1 minus cos 2x by 2 in place of sine square x, since it is an identity. Now you can expand the 1 minus cos 2x, and also 1 by 4 can be brought out of the integral. And also you can replace the cos square 2x by 1 plus cos 4x divided by 2. You can integrate each term separately. Now you can figure out the solution by evaluating this expression. Let me clear the area. You can cancel out 2 here. You can take the LCM in this numerator. You can multiply 1 by 4 in the inner bracket. Now you can solve these 2 terms as a single. The rest remains the same. This is the final answer of our integral. So we have done these 3 problems, and note that in first case we extracted the cosecant x the first place, and in the second one we have extracted the second square x, and in the third one we could not extract the sine x because it is an odd trigonometric ratio having the even power. We have converted the sine x into sine 2x or cos 2x based on the compound trigonometric identity. Okay, so hope you enjoyed the tutorial, and make sure you subscribe my channel and also click the bell icon so that you can be notified every time when I upload a new video. Stay tuned and stay safe in Corona vacation.